Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105.
This video is all about the summary of the chapter 7 and the chapter 7 entitled IP addressing. IPv4 network addresses, binary and decimal conversion. IPv4 addresses consists of string of 32 bits divided into 4 sections called octets. Each octet contains 8 bits separated with a dot. So just like this one. So the 192.168.10.10. So they are separated with a dot. So that is in binary. So 11000000 and for the 168, so that is 10101000. Then instant, so that is a 00001010. So again for 10 is 00001010. Conversion between binary to decimal. Use the chart to help with conversion. So you have the positional value. So let's start with 10. So we will convert that decimal 10 into binary. So uh, you will ask if 10 is greater than or equal to 128. So if no, so you will put 0. So 64 also is no, 32 also is no, and the 16 is also no. So the 8 is 10 greater than or equal to 8. So yes, so we will put 1 there. Then next is 10 minus 8, so it is a 2. Is 4 greater than or equal to 2? So no, so that's why it's 0. Then it's 2, and 2 is greater than or equal to 2, so yes, so that's why it's 1. Uh, then 0 to 1, so just like that. The IPv4 unicast, broadcast, and multicast. IPv4 addressing assignment to a host. Static, type in manually. Uh, so you will type manually for the static. For the dynamic, so dynamic host configuration protocol or the DHCP. So it is a configure also. Then IPv4 communication. Unicast send packets from one host to an individual host. So the unicast is from one-to-one connection. Then broadcast is send packets from one host to all the hosts in the network. So the broadcast is from one host into all of the hosts. Then the multicast send a packet from a one host to a selected group of hosts in the same or different network. So the multicast is it is from one host to a selected group of hosts only. So again, the unicast is from the one host to one individual host. Then the broadcast is from one host to all the hosts. Then the multicast is from one host to a selected group of hosts only. Then types of IPv4 addresses. Public and private IPv4 addresses. So there are two types of IPv4 address. So the first one is the public and second one is the private. So private address are not routed over the internet. So these are the examples of the private address. So 10.0.0.0/8 or the 10.0.0.02 send that 255.255.255. So just like that one. IPv6 network addresses. IPv4 issues. The need of IPv6. So IPv4 is not enough for us. So that's why we need the IPv6. So the definition of IPv4 address space. So we need the IPv6 because the address or the space of the IPv4 address is not enough, or it has a depletion. Then Internet of Everything. IPv4 and IPv6 coexistence. Dual stack IPv4 and IPv6 on the same network. So the IPv4 and IPv6 are in the same network, so that is a dual stack. Tunneling IPv6 packets inside IPv4. Then translation, IPv6 packet is translated to an IPv4 packet and vice versa. So in the dual, so they are in the same network. Tunneling is IPv6 is inside of the IPv4, and translation is IPv6 is translate to an IPv4 packets, and IPv4 packet translate to IPv6 packet. Then IPv6 addressing, IPv6 address representation. So the x colon 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 and x, where x represents 4 hexadecimal values. Apply the rules to simplify these IPv6 addresses. Rule number 1, omit leading zeros. So in IP addressing, so you will just omit the leading zeros. So if it start with 0, so you will just omit that or remove that. Rule number 2 is omit all 0 segments. So just like this one, you will just omit all the 0 segments. So if it, if the segments are all 0, so you will omit that. Then types of IPv6 addresses. IPv6 address types is the unicast, multicast, and telecast. So just like in the IPv4, so the unicast is from one host to another individual host. Then the multicast is from one host to a selected group of hosts. And then the anycast is for any one host to any host. Then testing and verification. Ping. Testing the local stack. Ping is a testing utility that uses ICMP echo request and echo reply messages to test connectivity between hosts. Ping works with both IPv4 and IPv6 hosts. Ping testing connectivity. The local LAN. You can also use ping to test the availability of the host to communicate on the local network. This is generally done by pinging the IPv6 or IP address of the gateway of the host. A ping to the gateway indicates that the host and the router interface service as the gateway are both operational on the local network. Ping testing connectivity to remote. Ping can also be used to test the ability of a host to communicate across an inter-network. The local host can ping an operational IPv4 host of a remote network. So, ping testing the local stack. So, the for the summary of this, so the ping is uses the it used to test the connectivity. So, for example, so you have the two networks. So you want to, and you have the PC 1, 2, and then the other network has a 3, 4. So they're both connected to a router. So uh, you if you want to say to test their connectivity, so we'll just ping the just like for example, you will use the PC one. So you will ping the or test the result of test the connectivity between PC1 and PC4. So you will just type the in the command prompt. So you will just type the ping and the IP address of the IPv4. Then if you got 4 replies, so it means that you have the connectivity. Then traceroute, testing the path. Traceroute is a utility that generates a list of hops that were successfully reached along the path. This list can provide important verification and troubleshooting information. If the data reaches the destination, then the trace lists the interface of every router in the path between the hosts. If the data fails at some hop along the way, the address of the last router that responded to the trace can provide an indication of where the problem or security restrictions are found. So the trace route is just like it is testing the path. So on how the message is delivered to the destination host. So thank you. So that's all for this video. Thank you for watching.